Good morning. Okay, I'm going to show how to solve the second order differential equation d2y dx2 plus 2 dy dx plus 3y equal to 17 cos 2x using Maple and Python. Okay, first of all, Maple, I will clear the memory by calling the restart. Later on, I will call the package with plots. Can plot all kind of the plot options there. I think I will just use a simple plot. Where's the plot? Let's see. Okay, and then I will define the ODE. Let's say ODE. Okay, colon equal. The assignment in Maple, make sure colon equal second order. So you choose a calculus template. Okay, second derivative. Okay, the f you change it to yx. Okay, we have 2 divided x. 2 multiply. Make sure you type the asterisk 2 times dy dx here. So f change to yx. Okay, and then plus 3y 3 times. So you see, make sure you type the asterisk there. 3 times yx equal to 17 times cos 2 times x. So for any function in Maple, make sure you open close bracket. So you see the natural display. d2y dx2 plus 2 dy dx plus 3yx equal to 17 cos 2x. Okay, and then for Python's, okay, you need to import the related library. The first one is for the plotting. NumPy is for the mathematical calculations. Okay, when you when you get the here, you can save a copy in your drive. It will create a collapse, collapse notebook, and will create a copy in your collapse, notebook. Mean when I save a copy in drive. So you see copy of ODE, and you can click here to change the title of the file. So you can go to your Google Drive in the collapse notebook. You have copy of ODE here. Okay, after that, we like Maple also, you got to define the like MATLAB, the variable x, y these are symbolic calculation. Okay, of course, Maple will be more user-friendly compared to Python and MATLAB. Okay, Python and MATLAB are suitable for numerical calculation. So from SymPy, import symbols. So you import the symbol functions, dissolve to solve the ODE analytically. Import the equations, the cos function. If you got sin, then import the sin function. Okay. So define x as a symbol, define y as a function, and then define the differential equations. So this is the equation. So you have EQ, okay, yx times d, this is differentiate x 2 times. Mean it differentiate y respect to x. Okay, this one mean differentiate y respect to x 2 times plus 2 times yx times d dff(x), so mean differentiate y respect to x. So this will be 2 times dy dx plus 3 times yx equal, the equal, in the Python syntax is comma. So 17 times cos 2x. Okay, and then we use a dsolve ODE tool, and then we put it into variable solution here. Okay, so in Maple, let's say this one I call general solution. So in Python, if we want to call this a general solution, also can print, then this is general solution. Then you click the block to run it. So I print general solution dot right hand side. Just print the right hand side here. You see general solution in mapper will be colon equal, and then the same thing dsolve also. Dsolve. I'm going to solve ODE. Make sure it's case sensitive. If you type capital here, make sure capital. Dsolve ODE for the yx. So you get this is general solution. You have C2 exponent negative x sin square root 2 sub 2x. Here you see. Here is C1 sin square root 2 times x plus C. Okay, here's C1, but in Python C2 cos sub 2x. Okay, plus 4 sin x minus cos 2x. So Mapper is more natural display compared to Python. Okay, and if you want to get particular solution, so PAR, particular solution, colon equal dsolve ODE. Okay, we are going to put in the initial condition. So this curly bracket, solve ODE. Okay, let's say what are the initial condition given. Okay, y0 equal to 0, y prime 0 equal to 7. So y0 equal to 0, and then y prime will be dy 0 equal to 7. Close the curly bracket and then close the round bracket. So we obtain the particular solution. So you see this is a Python, the particular solution. Same, right? Yeah. You provide the initial conditions. Okay, in the Python, we label as initial underscore condition equal to here curly bracket y bracket 0 colon 0. So colon 0 in Mapper is y0 equals 0, but in Python is colon 0, and then comma. Okay, here in Mapper d bracket y bracket 0 equal to 7 stand for y prime 0 equal to 7. In Python, okay, yx dot diffx, so mean dy dx. Okay, you got dot substitute, you have to substitute x equal to 0, so mean okay when y prime when x0 equal to 7, and then you call a solution with initial condition, or you can, if you don't like this name, you can put it particular solution equal to dsolve ODE2 comma ICS equal to initial conditions equal to initial condition. Later on you print here particular solution equal, this is the label, so the solution with ICS.RHS. So you see both Mapper and Python give the same solution. Okay, later on if I want to plot this particular solution, so I will call plot. Okay, plot. Later on I will plot the right hand side of particular solution. Okay, and then let's say I want to plot x from negative 10 until 10. Press receive a, okay, hold on, sir. Oh, here because the particular LAR, okay, LAR, particular solution is here. Then plot, okay, plot the right hand side here. Mean plot this function RHS bracket particular solution from x negative 10 to 10. Okay, how about the Python? Python, we need to, okay, the solution with, okay, initial conditions here, we need to assign it into a y, okay, name it as a y underscore function. We need, okay, we need it to assign to the y function, and then we need to define the range, okay, for the x. Mapper uses straight x equal negative 10 dot dot 10, but Python x, okay, I call it as x underscore values is a numpy dot linear space. Will generate a list of number from -10 to 10 with total 100 point there. Okay, if you don't want so many point, you can change it to, let's say, 10 point. So mean if you change, okay, from -10 to 10, you, okay, assign 10, okay, number of point there. And then y value, okay, y value will be, okay, you need the y function dot substitute x value dot eval f for x, for value in x value. Mean for all the value in the x value, for all the value in x value, mean we are going to actually, what the Python do is actually, okay, for x from -10 to 10, -10 to 10, got total -10 to 10, how many, okay, discretization there is total 100 point there. For each point, we will substitute all the value there so that you get the, okay, so that we can get the y function value, okay, y function value. So this is what we call, put it as a variable y values. Then if you compare the plot, okay, in Maple exactly we plot, okay, plot your function, then what the x from -10 to 10. But for Python, okay, we have plt dot plot, plot x, okay, x first, x, y. Like I think MATLAB also plot x and then y, x value, y values. Okay, label, okay, so label, when you run it, let's see, when you run it, you have here, okay, the label here is a legend, particular solution. Okay, we label the x as a x, yeah, label y-axis as a y. Okay, the title of this, okay, graph, okay, is actually solve d2y dx2 plus 2dy dx plus 3y equal to 17 cos 2x with the initial condition y0 equal to 1, dy0 equal to 7. Okay, and then show the legend, the grids through, then show it. So you can see both, okay, Maple and Python give the same solution, but I think Maple will be more straightforward and is natural display compared to Python. But for numerical solution, Python will be faster compared to Maple. Maple is good at symbolic, but Python freeware. Compared to MATLAB, you need to buy the license. Okay, and then Python is free. So both Python and MATLAB are good at numerical calculation. Okay, with this, okay, thank you for watching the video.